Morning, everyone. How are we all doing? Good? It's been a decent morning so far? Long morning? All right. Well, I'm going to talk about our vision at Brocade on how we help migrate to IPv6. I'm going to talk about it in a few different terms. Certainly, I'm going to talk a little bit about the technology, but when I'm having conversations with both enterprises and providers, the discussion that takes up at least half of the time is around the business case side of the problem. How do we get started? How do we justify the spend? I mean, I think we all understand that the long-term strategy for v6 has to be a dual stack world. We will be in a world where we've got v4 addresses and v4-enabled clients forever, but v6 is inescapably now. And so in light of that, how do we start taking steps from where we are today towards that world? That's what I want to talk about today in our time. If there's one thing I would ask you to take away from this, it's to start small. Build particular projects that are bite-sized, that have a clear business value proposition to them that you can justify to your leadership team, secure the funding, and begin the process. Once you get started, things get easier and things will snowball. Your organization will get more competency, you'll have more technology in-house, but find those initial projects to get you started. One of the things against that backdrop that I want to talk about, I hope to want to talk about, I will talk about, is the number of places where we can look for those initial projects. It's easy to think about home broadband users and how we have connectivity into them. But of course, when we think about who early adopters of v6 are, it is both people who have the exhaustion issue, but it's also people who are building large-scale networks from scratch. RFID-enabled environments are one good place. Smart grid and smart sensor-enabled places are another one. I was recently talking with someone who was at a train convention. This is a full-fledged, honest-to-God train convention, not a technology convention, people who deal with the latest rail car technology. A huge discussion about the role of IPv6 in building out sensor networks for next-generation rail networks. If you're going to put a sensor on every single piece of track from here to Albuquerque, there's no other way to do that than going v6 native in that environment. Plus, you get some of the benefits of end-to-end connectivity, because those tend to be systems that are built out by consortiums, so you want it to be all public addressing space. Those are great examples of places where people can find early adopters of the technology to provide your services to them, and again, do those initial projects to get you started. So my message here is, think about more than just people with laptops or iPhones or iPads when you're thinking about places where v6 is going to get its early sets of adoptions. Now, the next comment, this is not going in the right direction. The next comment that I would have is magic. Is to focus in on the business problem before you get to the technology problem. When we are working with folks, this is, I think, a critical success factor for those who have successful initial experiences with v6, that their leadership team feels is successful, versus those who don't. The challenge that we as a v6 community have often had is our inability to articulate clear business problems that we're solving to then justify the technology spend. At the highest level, everyone understands the exhaustion problem, and everybody understands that with IANA's depletion and all the RIRs starting to run out, that there is a compelling event that we all need to be tracking. But the question is, how do I make that relevant for me and my business? Right? If I am a local real estate agent or local real estate agency, how do I rationalize doing something now versus some other time in the future? And the two places where we've seen the easiest task of creating those business cases lie in either the enterprise side with an ability to communicate to v6 only clients that are coming on board. We've got folks like Telefonica and others, T-Mobile, talking about a world in 2012 where we'll begin to see v6 only mobile handsets. And so if you can wrap your brain around a group of clients that are natively going to want to talk v6, perhaps they'll have a translation system in place or some other migration technology to bridge them back into the v4 world, but inevitably a native v6 communication with that client is going to be a superior conversation and a superior user experience. So if your business or your client's business has a need to talk to those new people, then public services is a great place to start. Right? My content that I'm going to deliver to those environments, my e-commerce environment where I'm going to want to communicate with those people. If I'm a governmental organization, there's an obvious equal access to citizenry argument to be made here. It's communication with your end customer becomes the argument to get you started. Now the good news to this, as has been said a couple of times so far in the sessions, is that that is a tractable problem. It's a good example of one where you can start relatively small, because it really comes down to two primary technical challenges that you then need to solve. One, I need the services themselves to be able to talk on IPv6, which either means I take the service itself towards dual stack, or I put a translation element in front of the service, and I control that translation element, and therefore I feel comfortable that I'm not going to break the content. I do need that part solved, and then I need the uplink problem. I need to start working with a provider who's going to have a v6 pipe or a dual stack pipe to me, and I need my edge environment and my core environment to be able to talk v6. Relative to the size of an average enterprise network, those are very, very tractable problems, places where you can go, create a project, get funding for it, and drive an ROI model on that that's relatively straightforward. As I'll talk about in a little bit later, for Brocade IT, that was how we got started. Brocade IT, it's funny, as a technology company, our CIO is one of the more frustrated CIOs out there, as are all technology CIOs, because there's this vision that when you're a technology company, that technology then becomes magically free. Our CIO faces the same challenges that any CIO does. He gets a great price on some great networking gear, but beyond that, he's got staffing problems, he's got ROI models that our CFO and CEO are trying to put in front of him. He can't just do projects for technology reasons. They've got to be business reasons. And so Brocade IT took the exact approach that I'm outlining based on a hard-nosed business case that I'll talk about in a few slides. So that's the first place that we see opportunity. The second one is we're seeing a lot of providers start to recognize that there's an opportunity to help enterprises make this transition. Again, clearly if you're a broadband provider, whether you're a wireline or mobile, you've got to solve the address exhaustion problem, and clearly we've talked at length about that problem over the course of this. But I think it's important to also see the opportunity. As we start bringing more v6 clients on board, your business clientele are going to need help talking to those people. Now, some of the more technology savvy ones may choose to do what we just talked about and do it themselves. But many are going to look for providers to help them. And this don't have to be the large global tier 1 providers doing it. Local and regional providers have an ability to build new revenue generating service offerings, helping enterprises make this transition. I mean, remember, the whole reason why we're here is that knowledge and expertise on IPv6 is a scarce resource today. So there's an ability for a while for people to monetize that expertise, and in doing so grow their in-house experience and expertise with IPv6. So this is the most important thing in my mind. Understanding clearly how to have the business conversation with the leadership team in order to get started on projects. Once we do that, then we can start building out the technology problems that get us there. Now, as we said before, the long-term vision is service availability to both populations of users, both IPv4 legacy users and new IPv6 users. And the way to do that technologically is move to a complete dual stack system end to end. But it's taken us how many decades to build the internet? How many trillions of dollars worth of spend in that? Again, we got to break that up in pieces and get there in stages. And so I would suggest breaking that down into 3 sub-projects that offer near-term opportunity. First, building from the bottom up, as we said, you got to be able to talk v6 to the public v6 internet, which means working your internet edge, working with your providers, and exhibiting preference to providers that are going to offer you a v6 circuit is real important. It's also very helpful to all of us as a community, because the more the provider community sees business demand for v6 circuits, the more we're going to see adoption of v6 throughout the provider community as well. So start with your edge. We found a number of challenges in Brocade when we went to go and do this. Now, we've been on the public v6 internet with the entirety of Brocade.com since about midway through last year, well in advance of World v6 Day. So that it's gotten better since we did it, but it's still challenging to deal with things like redundancy and resiliency, address mapping from different providers. Some of the peering relationships are not designed for sort of enterprise-grade resiliency. So you got to work through that exercise, but it's relatively straightforward, and most of the regional providers now are pretty good at having that discussion. The second thing I would say is you may find you have particular parts of your business that are going to become an island, either a v4 only island or a v6 only island. Now, we've seen this more in different parts of the provider community. Cable and broadband providers, hosting providers start to run into this issue where you've got legacy systems that you can't upgrade, and so dealing with those islands and enabling interoperability is another great way to get started on v6 using translation technology. Finally, the v6 presence use case that we were just talking about, how do I take my existing public services and enable them on the v6 internet? It's a great business case to get started on, because the ability to talk to your customers is a pretty clear and easily understood value proposition at an executive level. No executive ever wants to be in a position where they can't talk to current or future customers. That's the linchpin we often see working in people getting started with v6. So from there, now, I am going to figure this technology out. From there, what does that mean in terms of technology? Well, on a moving towards dual stack, right, you want to get there in natural refresh cycles. So that becomes the first technology message. And I think it's been repeated over and over again at the conference. I'll do it one more time. Don't buy anything that's not dual stack capable. Just categorically at this point, from this point forward, don't buy anything that's not dual stack capable. Really important that we drive that message through the procurement process to allow us to migrate there at our own time frame. Now, when you look at what I want to do to start moving my core and my internet edge there, right, you want to be thinking about two main problem sets. You want to be thinking, obviously, about the core transport problem, but you also want to be thinking about both visibility and security. In many organizations, I've seen the driver to move to v6 ultimately be a security driver, meaning there are so many easy ways for nefarious folks to create tunnels across your environment into which you've got no visibility. It's much like it was when wireless was in its infancy. One of the drivers to get to campus wireless deployments was to have visibility and to get rid of some of the rogue APs that are proliferating around in your environment. You got the same notion here. You can tunnel anything over v6. I was talking with a security officer at a large corporation recently who was telling me, I want to get this right, he had experienced in his environment someone tunneling v4 malware over PPP, over Ethernet, over v6, over v4, over Ethernet. There's this massive set of tunnel headers there that were all for the purpose of hiding from existing security mechanisms. You need to be able to see inside those v6 tunnels. You need visibility into v6 tunnels in order to understand what's flowing over your environment. So that security use case and visibility use case can also be part of how you justify these kind of services. I am going to figure this out. When you look at the interoperability problem, we've talked a lot over the course of the conference about technologies like NAT6.4. I'm a big believer in that technology. I'm seeing it adopted to solve some real problems, and I'll show you a few use cases on that in a few pieces, or in a few slides. And the v4 or v6 presence, the guidance that I tend to give and that I hear most commonly used by people who are actually deploying this is as follows. When I want to take a public service, say my web server or my mail server, and move it from v4 to v6, I've got a choice, as we said before. I either go dual stack on the server, or I put a translation solution in front of it. If you have new operating systems that have native and robust support for v6, and you've got applications that are designed to work on those new operating systems, go dual stack. Absolutely categorically go dual stack. It's better to do v6 on the endpoint if you can. If you don't, and unfortunately most of us don't ubiquitously across our environment, have new OSs with modern up-to-date application stacks sitting on them, then you're more likely to achieve success, at least at a first pass, looking at a translation system rather than trying to get that application to natively support dual stack. So when you do the upgrade cycles on all of those application components, you will ultimately get them all to dual stack. But you may have some of these application components around for a long time, and doing an in-cycle upgrade on those often is more pain than it gives you benefit. And again, those are great application environments where it's worthwhile doing v6 translation. I mentioned the Brocade IT case. I'll come back to that a number of times. We found, because our objective was to support HTTP, all of Brocade.com, DNS, and SMTP. The philosophy was we want people to be able to do business with us over IPv6. You've got to be able to email us, you've got to be able to find us, and you've got to be able to go to our website. We found that when we explored our infrastructure, different pieces were at different stages on that v6 readiness. Some of our web infrastructure was brand spanking new, we just rolled the project out, it was easy to turn on v4 and v6. Other systems, not so much. Other systems were much more suited to a quick ROI model with a translation solution built on top of the load balancer that we already had in place. So let me talk to you just briefly about our technology. The ADX platform is Brocade's flagship load balancing platform and application delivery platform. Our focus with this product has always been environments that are very, very sensitive to performance. So large carriers, content providers, hosting providers, financial services, places where high scalability and extremely low latency matter, which we found to be a very good fit for some of these translation cases. If I'm going to introduce a translation layer between the client and the end user, we obviously have to be concerned about client experience, because the whole ROI model, the whole business model that we've talked about goes out the window if in getting that connectivity, I start negatively impacting user experience. Users won't come to my website if my website goes slow as a result of my strategy. So low latency and high performance has really been key to that from the beginning. The other thing I would say on this that we've put a lot of historic attention into is the security problem set. One of the other things to consider when you think about putting translation systems in as part of your solution, as part of your migration strategy, is that these devices do introduce points of vulnerability in your environment. Like any other system, these are subject to attack, and in particular, they're subject to denial of service attacks. So we've built into our platform incredibly rigorous denial of service protections. Our high-end platform can do 120 million SYNs per second that it can stand up to in a DOS attack environment. Those are the kinds of things you want to be thinking about when you think about a translation strategy to solve some of these business problems. The other part of our portfolio, and this is a case where Brocade is pretty uniquely positioned, of course, is our MLX family of internet routers. We've got both application technology that we can bring to bear on the translation problem and high-end routing technology to enable the tunneling solutions over top of MPLS and others. The thing I would say is when you think about tunneling, you tend to want to think about routing platforms as a great way of solving that problem, because that's fundamentally a connectivity problem. I would argue when you think about translation, you want to be thinking about application platforms. And here's why. Many of us learned the hard way through firewalling in the v4 world how integrally tied layer 3 and layer 7 are in the v4 world. That's going to continue through in v6. You've got protocols like SIP with embedded IP addressing. You've got to have the ability to go in, understand what's happening at the application layer in layer 7 headers and above, and manipulate them if you're going to make the translation gateway work. So you want to think about solutions for translation that are fundamentally application aware, whereas again, I would argue on the tunneling problem set. You want to be looking at solutions that are about scale and connectivity. So let me show you a couple of use cases of people using this and some of the experiences we've had. I've mentioned Brocade IT a number of times. I really do like that example because it's very real, and as I said, there's no magic here. Our guys face the same challenges that everybody else does. This was described, the guy's name is Kelly Brown, who's our manager in our IT shop who's responsible for this technology. He described this as about a 6-week project from start to finish, and he said the most challenging piece of it, as we talked about before, was working with our upstream circuit providers to get the connectivity through the core right, and in particular in solving the resiliency problem and the HA problem, because we needed redundant uplinks. Once we got through that part, as I said earlier, we have a series of back-end servers, some of which are native v4, some of which are native dual stack, and in one case, one of the SMTP servers is actually native v6. It's not a dual stack server. To solve that particular use case, we found it more stable to have a v4 SMTP server and a v6 SMTP server sitting beside it rather than running dual stack, because fundamentally with that particular system, we were a little uncomfortable with the IP stack on that system. So that's another strategy to try and get you there by having that dual stack spread across 2 servers. And in that case, we are providing a common front end in front of the load balancer where we're announcing both an A record and a quad A record through DNS that point to VIP addresses, virtual IP addresses, that point against the backset of these services. Now, to come back to the very beginning part of our conversation, I made the point that it's really important to get a crisp business case in order to kick these projects off. As I said, we did this about 8 months in advance of World IPv6 Day. And I'll tell you, we didn't do it for any kind of marketing or eating our own dog food kind of reasons. We did this for a very specific reason. Our federal sales teams came to us and said, hey guys, the federal government has been trying to work with the vendor community for over a decade to try and get them to support IPv6. And the vendor community responds by doing the minimal amount to make the federal government happy and no more. Right? The federal government tries to come up with these certification processes, and we as vendors do the minimal amount to jump over that bar, and then when they actually try and implement it, it doesn't work. So we're going to change the game, said the federal government. We are going to exhibit preference in the procurement process for vendors who actually deploy their own gear. If it works for you, it'll probably work for us. And this was the way of solving all of the little operational challenges that are so important to get these systems to work in live production environments without having to do it via the checklist methodology the federal government typically does. That was the business case that drove us through this, a very real need to demonstrate competency to our customers in order to drive business. That got this project approved in a matter of weeks and got the project implemented in a matter of months. Very, very important use case there. Second one I want to talk about is a large cable provider. This is really interesting. Large cable MSO who has literally millions of IPv4 only set-top boxes. These are boxes spread in markets in a lot of various geographically disparate environments. They're actually addressed today using 1918 space. They're 10net. And there are so many of them, they've actually already overwhelmed 10net. So they're reusing addresses, private addressing, even in their own environment. Now, they have built out a shiny new IPv6 backbone. It's great. Not much traffic on it, but the thing is awesome. Designed from the ground up for what they want. They've got a big mandate to embrace IPv6, and they've bought shiny new video on demand servers for all their IP-based video services down to those set-top boxes. Those are v6 only as well that sit on this new v6 backbone. Well, they got a problem. I've got a bunch of v4 only set-top boxes that need to talk over this v6 backbone to the new v6 video on demand servers. How do I deal with this? Well, using a technology like NAT64 is a very simple way to approach this problem. You prepend a 96-bit prefix on the front of it, maintain your existing addressing scheme, and allow those set-top boxes out of their v4 only world into this new v6 backbone. The reason I like this use case is really 2 reasons. One, we worked with the provider to do some special DNS work such that you don't have to do the translation entries natively on the device. You can actually use your DNS infrastructure to store all of that information. This isn't fundamentally mandated. It's not part of the DNS, or excuse me, the NAT64 spec, but it's a really useful way of scaling these kind of solutions into the millions of addresses. That's the first point. Second point was we found in working with these guys that a second business case emerged out of this. By appending a 96-bit prefix on front of that 10net, and then by changing what that prefix was for each of the different regions, they actually had the effect of taking what used to be private address space and turning it into globally routable address space, which meant you could now offer a whole host of over-the-top services to uniquely addressable set-top boxes. You could now talk with third-party providers directly to your own client. Enables a whole new opportunity for their marketing teams to deliver services and build value-added services through partnerships with third parties. Very, very interesting value that came out of this kind of solution. Third use case I want to talk about is a large hosting provider. This was a great example of where some of the call to actions that some of the sponsors of V6 actually had a positive effect. So at NANOG last year in September, when Aaron stood up and said, the sky is falling, it's finally here, guys, we're running out of addresses, this hosting provider, who's been a good friend of ours, a longtime customer, said to us, we have, we believe, a business continuity problem. And it's amazing the difference in how executives respond to the words business continuity versus thought leadership. Thought leadership, we want to be the first to embrace IPv6, our customers are really going to like it. Executives don't tend to care. Business continuity, IP addresses, publicly routable IP addresses are a scarce resource for our business. If we run out of v4 addresses, we can't onboard new clients. There's a business continuity problem. There's a fundamental threat to our business. Their executive team went, you're absolutely right. I want a solution installed in 250 days. Go. Which then caused these guys to realize that perhaps they needed to have figured out what their plan was before they fired up the executive team. But it had a good effect. They are now using NAT64 in production to solve this problem. They can now bring new V6 only customers on board and have them communicate back to traditional v4 services. And this is a good example, in my mind, of where the application relevancy comes in. A couple of people made the comment earlier on the need for logging these kind of systems, and I would wholeheartedly agree with that. What we found in this case was not only did they need to be able to log the translation, the ability to say, all right, this client is actually tied to this sets of IP addresses and source ports on the other side of the translation gateway, so if I've got a security event, I can trace it back. But I also want that to show up in my web server logs. So how do you solve that problem? Pretty straightforward. You take the client's IPv6 address and you insert that as an HTTP header. Right? It's just another header. The web server logs on the web server side are able to decode that, and you can now uniquely identify on the server logs themselves, with no need of correlation to some syslog server somewhere, the user of that website. You can continue to log all of their transactions on the website. Very, very powerful and very important example of where you need the ability to take layer 3 information and inject it up into layer 7 technologies. So, I hope this was interesting. The final pitch that I would say to you guys from a product standpoint is just think about scale when you're deploying these kind of systems. As much as at first, we all know that the traffic right now is quite small, we all know that once we make investments in these kind of systems, they're around for a long time. So think about scale up front when you're trying to figure out how you implement this technology. I'll come back to my message that I started with. When we look at IPv6, clearly the first thing we all got to do is demand v6 support and dual stack support in every product we purchase going forward. That's just essential, even if you're not going to turn it on today. But the more important point that I want to drive home is clarity on the business case, because I think it's there. I think we can clearly make arguments for first step projects that allow us to start implementing this technology or allow us to help customers implement this technology that gets them started. Because once they get started, all of the follow-on solutions that drive towards the world of dual stack come into focus. Thank you all very much.